Hello. What we're going to be presenting for you today is a lab that was prepared for Penn State University's IST 515 final term project for the spring of 2013. Our teams were composed of 3 members each, and this is for Team 14. The members are Jason Lands, Kirk McKenzie, as well as Benjamin Tedesco. You can see our email addresses are right here in case you have any questions. So what we're going to be doing today is walking you through some of the research that we've compiled regarding vulnerabilities associated with USB devices. Specifically, what we'll be doing is 3 parts to this lab. In the first phase, we're going to be actually working to create a Keylogger piece of malware that then will be put onto a USB device. Specifically, we're going to be exploiting a vulnerability called the U3 vulnerability. And after we have successfully created our piece of malware, what we're going to be doing then is we're going to show you how to load that malware onto a USB key device. Once that's been loaded on, you will then be able to watch as we infect a target system. This is, of course, a safe system in a controlled environment. And then we'll also walk you through various means by which you might be able to protect or defend against this style of intrusion. So let's get started. First of all, what is a USB thumb drive? Well, as most people are aware, it's a very convenient way to store and manage file transfer and sharing between people within an enterprise. If you don't have access to a network, you can just quickly hand someone your USB key. They can install or put their files on that they want to give you, and then you can go take that somewhere else. Most people believe that since it's not connected to a network and it's just simply a storage device, that for the most part it's safe. However, what we're here to demonstrate is that just because it is not connected to the internet directly all the time does not mean that it is not a potential target for an adversary to attempt to compromise your network. In fact, USB drives can contain rootkits that are extremely dangerous because then they run at kernel level on your system. And another thing actually that we wanted to point out here is that especially in environments that possibly are or are technically supposed to be isolated from the network, e.g. a classified environment, this is a common means for an adversary to gain access to very secluded data because they can use a USB key as a method for infiltration as well as a potential method for exfiltration. So as we're going through this lab, what we've put together is sort of a attack scenario. The goal behind this is simply to make this a more relatable and hopefully more practical lesson as we are walking through this example in this lab. So what we have here is our adversary bad guy named John, and he visits the bank and he goes to the front counter acting like he simply wants to purchase a money order. However, of course, he is here for a specific intent besides purchasing this money order. Well, he then goes, and on his way out he casually sets his hostile USB key, the one that we're going to show you how to make later on one of the teller's desks and exits the premises. After a little while, the unsuspecting teller then walks by their desk and sees the USB key. In an attempt to discover what in the world's on the USB key and hopefully maybe to determine its origin if someone accidentally left it there, the teller plugs the USB device into his computer and is instantly compromised. What happens next and the potential mitigations will be discussed throughout the length of this presentation. So to summarize before we get started here, the objectives of this lab are threefold. Number one, we're going to educate you, the user, on the current vulnerabilities associated with USB key devices. Hopefully we're going to provide you with some current and new information that we've compiled very recently regarding this emerging threat. Number two, we're going to build and deploy the USB exploit kit. It's going to be called the U3 AutoRun attacks, the specific one that we're going to be doing, and we're actually going to be deploying a custom Keylogger Trojan that we build along the way as well. And then lastly, we're all going to show you how to protect and basically mitigate USB exploits using a few registry hacks, as well as a few COTS products and other solutions that we found that would help defend against this particular style of attack. Okay, so as far as our lab goes, we are assuming that you're going to be running a Windows-based system and that your target is also a Windows system. For the USB drive, we're just going to be using a standard SanDisk U3 USB device, and we need 3 applications here to get this thing to work the way we're doing it here. So the first one is some sort of ISO editing software. We're going to be using Magic ISO. And then you're going to need what's called an LP installer program, and that's something made by SanDisk specifically for these U3 drives. It's actually designed to write and update the firmware on these drives, but of course we'll be exploiting vulnerability and repurposing the software. And lastly, we'll need our piece of malware. In this case, we're going to be using a Keylogger Trojan. For the mitigation portions, we're going to be using just Microsoft's MMC management console here. You're going to want some sort of antivirus program. We've chose McAfee, and then a DLP solution. In this case, we chose the device lock endpoint solution. So the first thing that we're going to be doing is configuring and compiling our custom malware for excuse me, that will be deployed in the attack. So in this case, we just picked a keylogger that we found on the internet, and in here you can see some of the configurations. One thing that we noted was that normally, of course, you'll want to run the malware silently without the user knowing that it's there, but in this case, just to prove that this is in fact running, that it's working, we've left that option off so it is visible here. So as we continue to walk through the configuration of our keylogger malware that we're going to be deploying in this attack, this next screen basically asks for encryption options on the keylogger's collection file. This just ensures that if anyone else attempts to stumbles upon this file and then attempts to open it up, they'll be prevented from doing so. In this slide, you'll see something that was actually pretty interesting regarding this keylogger. It has a cleanup function in it, or actually, probably put it a better way, a means by which it can obfuscate itself from a user by actually deleting itself. In my malware analysis, especially over the past few months, and well, actually even I'd say over the past 2 years, this is becoming a technique that's more and more frequently being used in malware, where it will either hop around a drive or it will actually go and delete itself to attempt to hide its presence from a user. So the last thing that we need to configure is where the payload will be dropped off. This particular keylogger is actually pretty neat. What it will do is it has the feature here where it can just FTP the password protected collection file to a remote host. This happens when the file reaches a certain threshold, whether it's a certain size, or also it can be done on a periodic basis. So here we've just filled out a sample FTP host that will be receiving this drop file. So as you are now looking at the hard drive of the machine that just compiled this keylogger, you'll see a new file right here called install.exe, which is our handy dandy keylogger. Another thing that we've done to further obfuscate this file is we've changed the icon to make it look a lot more innocuous, and we'll be putting it on the U3 drive, so it looks a lot less like a, I don't know, an executable binary, more just kind of like a system file or something along those lines. So what we're showing in this screenshot is simply the FTP web server that we're going to be using to receive these drop files. The thing that you're going to look at is that test log folder, and that's going to be the one that holds all the files that are sent once this exploit has been completed. And as you see here, the test log folder that will be receiving the files once they're FTP'd from the infected host is indeed empty. So now that we have successfully created and configured our malware keylogger and then went on to obfuscate it to attempt to further disguise it, the next step in this exploit will be to download the U3 Launchpad installer. Basically what this is simply SanDisk's proprietary tool for loading and installing firmware onto their U3 drives. So what we did was we actually just went to the SanDisk website. It's http://u3.sandisk.com, and you can actually download the SanDisk Smart USB U3 installer. So once you've downloaded it, the welcome screen is going to look like this. An issue that we ran into actually was that you first need to plug your U3 USB device into the system, or it will lock you out. I guess that's just some sort of a security measure that SanDisk has put in place to make sure that you're not running this tool unless you actually have the U3 installer. So what you're going to do is you're going to run through the install here, and then you can actually go about loading our piece of malware onto your key that you're going to be using in the exploit. So as you're running through the Launchpad installer, you're going to eventually come to this screen right here. At this point, you need to stop. This is where we can actually grab the Pelican bfg-autorun.iso file that's going to be put into your temp folder. What we're going to do is we're actually going to be working with this file, and this will be cleaned up at the end of the install. So this is our opportunity to grab it so we can exploit it and make our own modifications on it. So after we have made our own modifications on it, then what we're going to do is we're going to then continue the installation process, and the newly modified ISO file will then be loaded onto the drive. So what you're looking at now is a view from Windows Explorer of the temporary folder that is created by the Launchpad installer. This folder is located at users, your username, appdata, roaming, u3 temp for Windows 7. Basically, inside this directory will be that ISO file that we're going to be modifying, and then will be loaded onto our USB key by the Launchpad installer. So what we want to do is open up the Pelican bfg-autorun.iso file that was located in that temporary folder that we just showed on the previous slide. What we're using to open up this ISO image is Magic ISO. Inside the ISO file, you'll see AutoRun.inf as well as the Launchpad.zip files. We're going to be editing these files, and then we're also going to be then adding our own file, the malware keylogger that we conveniently named install. So what we need to do is we need to update the AutoRun file found within the ISO file that we've opened up within our Magic ISO application. When you go and double click on the AutoRun.inf file within Magic ISO, it will just launch whatever text editor that you use. In this case, we're just using Notepad, and you'll be able to view the contents of the AutoRun.inf file. Basically what this file does is it tells the operating system what actions to complete when the drive is plugged in. As we look at this thing, you'll see there that big arrow right there. That's a line that we added in. The open install.exe basically tells the system to launch the application called install.exe. If you remember, install.exe is the name that we gave to our malware keylogger. So when this drive is plugged in, what we'll do is it'll launch our malware in addition to launching the U3 executable that this tool was intended for. So we just need to save this file, and it will overwrite the existing autorun.inf file. What you're seeing here is an issue that we ran into actually. This Launchpad application will only deploy an ISO file under 7.5 megabytes. The particular malware that we're using actually is 1.7 megs, and so that kind of pushed us over that 7.5 megabyte threshold. So what we actually had to do is we removed some of the extemporaneous language files that were also included in the package, and that got us beneath the ceiling of 7.5 megs here. So here we see the finalized, modified Pelican BFG AutoRun within Magic ISO. You'll notice that the AutoRun INF has changed in size from 309 bytes to 327 bytes. And then you'll also notice the new install.exe program that was also added to this newly modified ISO file. So what's going to happen next is we're going to save this, and then we will continue with the installation, and the compromised ISO file will be then loaded onto our infected USB key. So next we're going to go back to the original U3 Launchpad installer, that LP program that we downloaded, and we'll continue with the installation process here. This will enable the compromised ISO to then be copied over onto the USB key. So here what you see are simply the closeout screens from running the U3 LP application. Basically we're just going to click next, and it's going to install the ISO onto the USB key, and then we're going to hit finish to complete the installation successfully. Once we do this, you'll now have a fully functional attack USB key that has utilized the U3 method for exploiting and compromising the system. So now that we have compiled and configured our malware and then loaded it onto our USB attack drive using the U3 exploits, we now have moved to the section of the lab where we're going to begin testing and just verifying that this exploit did in fact work, and we can use this as a attack USB key. So as we go through this, these next few slides are just going to be showing the keylogger in action. Now what we want to remind you of is that, number one, this system, the target system that we've infected, is located in an isolated lab. It is not connected to the internet, and actually we have since destroyed the target system. It's actually a laptop, and we have re-imaged it, so there is no unexpected consequences resulting from this lab. Anyways, the other thing that we wanted to remind you of is that when configuring the keylogger, we did enable certain settings that normally an attacker would not enable, specifically the keylogger showing up in the taskbar. And then if you right click on the keylogger icon within the Windows taskbar, you also will be able to see a menu on it. Again, in a normal situation, these options would be hidden, so that way the keylogger would be running silently. But this was all just done simply so that we could ensure that everything was performing correctly. So on the screenshot below, you see exactly what it looks like on a target Windows 7 machine when you plug in our newly created USB attack key. The only evidence that the key has been plugged in is that this Andromax keylogger icon now shows up in the task list. That, again, we configured this. Normally you wouldn't want to do that. And when you right click on it, you can view the log, go in hidden mode, and do some of the other options associated with this particular keylogger. No other prompts show up, no windows pop up, nothing else happens. So this keylogger has the potential to completely run silently as soon as this USB key is plugged into your target system. So now that we've verified that the keylogger is running correctly on the target host, the next thing we want to do is we want to actually go and check the FTP server to see if anything has been sent over. In here we go to that test log directory, and we see that two new files have been created, an HTML file and a JPEG file. You remember before that this directory was empty, so these files have been just sent over by the compromised host, and more specifically by the malware keylogger that we have set up on that host. So what we're going to do is we're simply just going to copy these files down to our desktop so then we can view them and check out the contents. So what you see here as we take a look at the files that were sent over by the keylogger that we have hidden on the target host, we see an HTML web page actually that was created by the keylogger. It's pretty cool actually. You'll remember that there was a screenshot or an image that was also sent over. Basically that image is embedded on this HTML web page. And it's pretty cool too because this web page allows us to kind of get a fuller picture of exactly what's going on with the system at this particular time. So we have timestamps. We can see where the user has clicked, and we can also track whatever text was typed at this particular instant. So what we've been able to actually demonstrate through this is that we have a very successful means of monitoring this user, and in most cases we would have configured it so it would be a completely silent and unknown to the user, so they would have no clue that we were there, and yet we'd be having a very comprehensive kind of look at the system and what the user's activity is. So to conclude this phase of the lab, we've successfully demonstrated tactics, techniques, and procedures of utilizing the U3 exploit to successfully compromise and create an attacked USB key. We configured our malware keylogger and enabled a few options that we'd be able to demonstrate that this was indeed successful. We then compromised the manufacturer's USB firmware upgrade utility by modifying the manufacturer's ISO file by adding our own malicious binary to be launched when the attack drive was plugged in. After this, we of course had to compromise and attack our target host system, and then we allowed the binary to exfiltrate data that it collected from the infected host. After this, we simply went through the data that was now on our FTP host server that was dropped by the malware. In the next section of our lab, we will look at several different tools that could be used to prevent and defend against this style of attack. First method by which this style of attack could be prevented is by updating your registry to prevent any style of AutoRun from being launched by removable media. What we're going to do here is we're just going to use the Microsoft Management Console. So what you do is you go to Start, Run, and then type mmc.exe, and this will launch the console root directory that you see in the background there. From there, you just go to Add Snappin', and this next window will pop up here. From here, you'll select the Group Policy Object Editor, click Add, and then click OK. So now that you've loaded your group policy object into the console, what we're going to need to do is we're going to need to navigate the directory tree. So let's go click on Local Computer Policy, Computer Configuration, Administrative Templates, Windows Components, and then lastly AutoPlay Policies. What you're going to notice is that Microsoft has created 4 objects in here that can be tuned to your organization's security policy. Now by default, none of these are configured, so nothing's turned on. The first object that we're going to modify is the turn off autoplay. So by default, autoplay is not turned off. That allows CDs, USB keys, or any other removable media from automatically running applications or tools hopefully associated with its processes. In our case, we obviously ran a malicious binary that was not at all associated with our USB key. So what we need to do is double click on the turn off autoplay policy object, and then we're going to go select all drives. This will disable any drive from playing any sort of binary automatically. And then we just click apply and then OK. Another option that's available to you, and in this case it's redundant because we've turned off all autoplay, but if you decide not to turn off autoplay, another option that we can modify is the default AutoRun actions. In this case, what we're going to do is we're just going to double click on the default behavior for AutoRun key, and we're going to go select do not execute any AutoRun commands. So this allows us, let's say if there's some sort of AutoRun activity that we do want to allow, we just want to have the system not allow binaries to automatically execute. So this is a little bit less secure, and yet it's somewhat a nice hybrid in cases where AutoRun is actually useful and your organization does want to allow AutoRun in certain instances. So let's go over here and click do not execute any AutoRun commands, and then we'll again click apply and then OK. Another critical control in ensuring that your system is not vulnerable to these styles of threats is your antivirus software. In this case, what we did is we went through the McAfee antivirus suite, and there's actually a setting in here that you can actually go and ensure that whenever removable media is connected to the system, it is scanned automatically. Of course, your scans do you no good if your antivirus definitions are out of date, so you must ensure that your antivirus definitions are kept up to date. That way you can receive the latest signatures from your antivirus vendor. The last utility that we evaluated that would prevent these styles of compromises is this DLP tool, or data loss protection tool, called Device Lock. Device Lock actually adds a few other elements to group policy. It's very interesting that Device Lock actually has an anti-keylogger option. What this anti-keylogger option does is it actually pops up a warning on a user's desktop whenever a keylogger or potentially keylogging software is detected. In addition to doing the initial warning to the user, it blocks the keyloggers, and it also is very fascinating because in some cases it'll actually send garbled input to the keylogger. This feature will allow administrators to securely allow all single-function USB mice and keyboards and generic USB devices. However, it will prevent devices, especially hardware devices, that are meant for nefarious purposes to gather data without the user's knowledge. Another option available to those who are using this tool is that it has this feature called the Device Lock DLP Endpoint ContentLock filtering. Basically, Device Lock's content-aware rules are located under the permissions for both the devices and the protocols, and it matches the expected input and output for these devices with the actual expected input and output. This basically allows and ensures that the right data is coming in and the right data is coming out of the right devices. Another feature of this DLP tool is that it monitors the network protocols and it allows or denies certain access for specific users to network protocols. So for instance here, we could allow a user to use webmail, SMTP mail, and instant messaging, but block FTP, peer-to-peer, or other specific protocols that we do not want a particular user having access to. One of the fascinating aspects of this tool as well is that included in the group policy are very granular permissions for specific ports and devices on a per user basis. So we could allow or disallow users access to USB ports if we didn't want a particular user to have access to it, or particular devices that we would rather reserve for more technically savvy or administrative personnel. Where the capabilities of the Device Lock data loss protection capabilities really become practically useful is the USB device whitelisting capability. Basically, what this allows an administrator to do is to directly control specific USB devices and whitelist allowable devices. So let's say a company has 10 encrypted USB keys that are available to the forensics department. The administrator can go through the Active Directory and specifically allow these devices and allow specific users access to these devices. However, if a particular user attempts to try to use another device, that device will not be allowed. Or if one of these devices attempt to be accessed by an unauthorized user, that will also be blocked. Thus, only designated users will have access to authorized USB drives. Hopefully, this will prevent and actually cut down significantly the potential for malware to be brought in on a foreign USB key. That would have prevented the scenario that we walked through in this lab today. So we here from Team 14 of IST 515 hope that you found this lab to be informative as well as practical, as we've illustrated the vulnerabilities associated with USB devices in the scenario that we provided today. In addition to demonstrating these vulnerabilities, we actually walked you through the creation of a malware keylogger and how you might be able to tweak it to suit your individual needs depending upon the style of attack you wish to perform on the host. After we actually attacked the host, we walked through the data that was collected, and we then discussed several options available that might be able to help prevent and defend against this style of compromise. Those were group policy updates that would disable AutoRun in the registry, specific configurations for antivirus to automatically scan USB devices when they're plugged into the system, and then data loss prevention utilities. Kirk, Jason, and I would like to thank you very much for your time, and please feel free to email us if you have any questions or comments related to this presentation. Thank you very much.